We are in our final part of 1.2, okay, 1.2 part 3. With this, I have according to my lesson plans, it's going to take us today and tomorrow to get through it.
Yes.
Don't complain, right? You know. I would go ahead and have calculators by your side still because there's going to be some stuff we used to help with the calculators. But we've got 3 topics here to talk about. And then you have one last set of homework in this section, which is the 48 to 66 evens. So our first topic is even and odd functions. So being able to know if a function is even or if a function is odd and what that means in terms of its symmetry. Okay, so a little bit of vocab here. Functions that are considered even have symmetry across the y-axis. Okay, so if a function is what we call even, it is symmetric across the y-axis, which means it has vertical symmetry, right? Now, that's the graphically way. Algebraically, if a function is even, then f of x is equal to f of negative x. So there's 2 different ways to know if a function is even or not. I'm going to teach them both because here's the deal. Do we always have a calculator to where we can look at the graph?
Unfortunately, no.
We don't. Okay, so we need a plan B, and that is your algebraic. Okay. The other piece of this, functions that are considered odd have origin symmetry. So they are what we call symmetric about the origin, so symmetric about the point 0, 0. Better to show you an example when we get there. Okay, it's kind of a diagonal symmetry in a way. Algebraically, if a function is odd, then f of negative x equals negative f of x. Okay, it's kind of a double reflection there. So, we have 3 examples. Tell whether the functions are even, odd, or neither, and determine their symmetry. Once you know whether it's even, odd, or neither, you'll know how it's symmetric. Okay? My suggestion here is always start by testing 1. So test and see whether or not it's even. You know, if it's even, you're good. If it's not even, then I'm going to say test odd. If it's not even, it's not odd, then we know it's neither. Okay? And yeah, we can look at the graph here in a moment, but I don't want to just start with looking at the graph.
Yeah, guys.
Okay? Now, if I'm not looking at the graph algebraically, we know f of x is x squared minus 3 already, yes? The question is then, what is f of negative x?
It would just be the opposite, wouldn't it?
Not exactly. So this is f of x. Right here it's negative x. What I'm going to tell you is every place you see an x, replace it with negative x. Every place you see an x, replace it with negative x. So with that in mind, it's supposed to be x squared. Now I'm going to go negative x quantity squared minus 3. Well, what is negative x what is negative x, the quantity squared?
It's just x squared.
It becomes x squared, yes? And minus 3 is still minus 3. What do you notice right here?
F of negative x is equal to f of x.
Yeah.
Therefore, it's left correct.
Okay. So we found that it is true, based on our statement, based on what we just figured right here, these 2 are equal, right? So we did find that f of x is equal to f of negative x. And so, as stated, this is an even function. Okay? Now, by definition, because we know it's an even function, we also know it is, it was already said, symmetrical across the y-axis, right?
That right for money. Look for you if you did equal.
Now, we just did that algebraically. Technically, Could we have done it graphically from the beginning and never even looked at the algebra?
Yeah, none of us did that.
So, and in all honesty, folks, I had you guys in algebra too. It's not gonna, I'm missing the above lights, and so I'm gonna struggle with the graph here, I bet. Guys, x squared. X squared is a
Parabola.
parabola. What's the minus 3 do to it?
It makes it go down.
What
Three.
steps?
Yeah.
Yeah. It makes it move down 3.
Parabola.
And so, yeah, I don't think without the overhead lights, I don't think I can get my graph to show up a whole lot better. But you guys have it, right? It's a parabola moved down 3. Could you have just known that in your head and been like, oh, that's going to be symmetric across the y-axis? It's even.
Just a tap.
I'm just putting a sketch of a graph on here just to kind of indicate that, hey, there's your visual. It is even. Okay? Now, what I'm going to say, I'm not against you doing this graphically, but I need you to know the algebra too. Okay?
B.
Okay, B. We want to know, is it even, odd, or neither?
Well,
So first thing we're going to do,
set it or have the negative x. So actually it's even.
Yeah.
Which
we're going to start by finding
it's not.
g of negative x.
Statistically speaking.
Because that's testing even, okay? So every place I see n, x, we replace it with
Negative x.
negative x.
That's right.
So x squared is negative x raised to the second minus 2 times negative x minus 2.
Plus equals squared.
Okay. Negative x quantity squared becomes
X squared.
positive x squared.
Plus 2.
Negative 2 times negative x
Plus 2.
plus 2x minus 2.
Therefore, not equal.
Do not equal. Not happening today.
Okay, so right now,
Hey, graphs with the
we just figured out that there's a sign difference here, isn't it? So g of x does not equal g of negative x, and so, as it was stated, not even. Okay,
Now we got this for odd.
so strike out 1, or strike 1. Okay, B. Now I want to know, does f of negative x equal negative f of x? Okay, so we already have g of negative x. It's a matter of finding
Negative.
negative, and it's g of x in this point.
No.
Okay? Negative g of x. There's a negative out front of the function. So yes, that just means you take the whole function and multiply by a negative. So I'm going to write it as negative out front, and I'm going to put parentheses, x squared minus 2x minus 2. Just indicating that's what we do there. Take a negative, we're going to multiply it by the whole thing, which now means officially we're going to distribute. So it becomes negative x squared plus 2x and
Plus 2.
plus 2.
Not equal.
Does negative g of x match with g of negative x?
No.
No, we got two different signs there, don't we?
Therefore, it's not equal.
So g of negative x does not equal negative g of x. So officially at this point we know it's not odd. Well, if it's not even and it's not odd,
It's neither.
it's neither. Now, could you have possibly known that by looking at the graph?
Yeah.
Possibly.
No. That
What do I
was a
do?
big graph.
By the way, it took me a minute to remember the absolute value into some on the calculator. I had to play around for a while last night. Did a lot of testing.
Yeah, it's not like your
Yeah,
mom.
but I don't-
It's not like
I
you
don't-
couldn't have asked me.
You know what?
It's not
But
like
then
she's the
but then when-
teacher.
No,
There's
because
proof he doesn't
every-
always. He doesn't.
but
come
every
to me for a
time
lot.
I get the question, do you ask your mom for help on the homework? I always say no. I gotta keep that up.
And you wanted to keep that. There's there's rare occasions, but
I feel like being a calculator is different.
No. I don't want to hear any teacher's kid benefits crap.
Well,
okay, guys. Now,
I feel like ask her that she
with
says
this in mind, guys. Okay, did you look at this next one?
not yet. The calculator has. I'm just
Irrelevant.
Yeah.
Needed.
kidding. It's odd though. I can tell you that much.
No, I'm still at B.
Oh,
Sorry.
you're still on B. My bad.
Here's the deal. It is a parabola, yes, but it's an off-center parabola, right? So there's not where like diagonal quadrants are going to have some type of symmetry, which is what origin is. It's obviously not symmetric across the y-axis because that parabola is scooted over. So thus, it is the neither.
It's forward.
Okay. C.
Odd.
And we know even, odd, or neither. We're going to go through the steps, though.
Statistically, it's on.
I know.
Statistically.
It's on.
Okay, so
Yeah.
we're given with h of x. We need to start off finding what?
What one are we doing? Even first.
We're always going to do even first because here's the deal. The information you get from even, do you need it for odd? Yeah.
Kind of.
So you might as well test even first
Fair enough.
because you need to know f of negative x, or in this case, h of negative x, to be able to find odd. So you might as well find it first, test for even, and then we'll test for odd. So h of negative x. This is going to be negative x raised to the third over 4 minus negative x to the second. Okay. What is negative x raised to the third? Negative x to the third over 4 minus, what is negative x to the second?
6.
X to the second. So realize that's 4 minus x squared, right? Because you square that negative, it becomes positive, so that minus is still there. Okay,
Not equal.
so right here, negative x cubed and 4 minus x squared. What do we know?
It's not even.
Okay. We already had kind of assumed it was going to be not even, but now we just showed that h of x does not equal h of negative x.
Here.
Okay. Next step.
Boom.
Now I need to find
Negative h of x.
negative h of x. Now, listen carefully here. So I'm going to write this as, officially I'm going to put a negative out front and then parentheses, because it's, you multiply the whole function by a negative, right?
The original.
Well, here's the catch. Yes, the original function. How do you multiply a fraction by a negative?
You put it in, like, isn't it where you put it in the denominator? Or no, I was thinking of a negative exponent.
So, okay, to multiply a fraction, so for instance, if you were multiplying a fraction by negative 1, what is negative 1 as a fraction?
Negative.
Negative 1 over 1. So are you multiplying top and bottom by a negative?
No.
No, you're only multiplying,
The top,
okay, and here's what I'm going to say. You can multiply the top by a negative or
just
the bottom, but it's not both.
let's go.
And so here's what I'm going to do. I'm going to look back and see, where's it going to be more beneficial for me to multiply the negative in? Top or bottom?
The top.
The top is going to make it look right, doesn't it?
That's right.
So you multiply the top or the bottom by a negative. When we do that, this becomes, if I multiply the top, negative x cubed over 4 minus x squared stays.
I think we got a match.
Okay. What did we just show here?
The h of negative x is equal to negative h of x.
Yeah. So with that in mind, this is odd because h of negative x, oops, I just realized I forgot my not equal sign up there, does equal negative h of x.
Boom.
Now,
Cowabunga.
this is an important one to graph. Okay? Officially, according to the definition, what does odd mean? It is symmetric how?
Above the origin.
Okay, symmetric
There it is.
across the origin. Please take a peek at this graph, because I need you to understand what does symmetric across the origin mean.
It's reflective of itself, like it's in a mirror. Hey, how do you just get one of those to show up? Because whenever I do it, all of mine show up.
You just turn off the equal sign like you would like a plot. You just click left and then go to equal and turn it off.
So you see right here how only the Y3 has the dark equal sign? So when I click on the equal sign, I can turn it on and off. When it just says equals, it's turned off. When it's highlighted or darkened or whatever, it's turned on. And so now I'm only,
Turn it on by pressing enter on it.
yeah,
Yep.
just get on the, have your cursor be flashing on the equal sign.
You have to type something first.
Probably.
Or yeah.
Yeah, there has to be something typed in. Okay, guys. This one graphed in black, so that's helpful. Here is an example, symmetric about the origin. Okay? What I like to say. This is how my brain sees it. There's other ways, there's probably better ways to see it. But symmetric across the origin is basically symmetric across both axes at the same time. So here's what I like to do. Is I like to say, okay, if I take that bottom right quadrant, can you visualize? Take that bottom right quadrant, let's say flip it up across the x-axis, and then flip it over across the y-axis. Does it land on itself?
Yeah.
Okay, you can do that with any quadrant. I just picked one. If you pick the top right quadrant, if I flip it left across the y-axis and then down across the x-axis, does it land on itself?
Yeah.
Okay, that's what symmetric across. That's the easiest way I can describe symmetric across the origin. Is it's a reflection across both axes. Is that fair enough for you?
That works for me. I don't know about Paxton, but that works for me. Paxton, that work for you? Yeah. It works for Paxton. We do. P. Diddy understands it.
Okay.
Nobody like it.
Okay. Questions there? Okay. There's your even, odd, and neither.
Oh.
Test even, then test odd, and then if all else fails, it's neither. Okay. We ready to talk asymptotes?
Yeah, I guess so. No. Asymptotes aren't too bad. I say we skip the end behavior though.
Did you get your issue figured out?
No.
Just, I can tell there's an issue.
Oh, yeah.
It's just like nothing's coming. I haven't.
Uh-huh.
It's, I understand. Yeah, I changed.
So you clicked when we were asking. You clicked your graph off. So I just highlighted that.
No, you don't.
Yes, I do.
No, you don't.
Now,
You know what I do?
okay, now
No, you don't.
You know what I do?
did you use negative there?
Maybe.
No,
Oh, it's not supposed to be negative, but that shouldn't
I
matter.
don't know.
Okay, now it's graphed.
No, you do.
Now yours looks reversed in mine because I graphed the original,
Oh.
and you graphed the odd one. But yeah, so I don't know what the second issue was, but the first issue is you had unhighlighted equal sign, so you turned the graph off. I don't know if you accidentally or purposely did that, but. Okay. Asymptotes. We've talked about most of this already. Officially, this all goes back to Algebra 2. Okay, but we've also talked about some of this in pre-calc over the last week. Vertical asymptotes. Vertical asymptotes are places that make the denominator equal to 0.
0.
Okay? To find a vertical asymptote, set the denominator equal to 0. Now, it doesn't mention holes here, but in relation to yesterday, as long as the factor doesn't cancel, it's a vertical asymptote. If that factor in the denominator cancels,
Bless you. Bless you.
if that factor cancels, then it becomes a hole instead of a vertical asymptote. Horizontal asymptotes. Okay, we had this last year because last year you got a cheat sheet with the information on it for the test. That's why I remember that Algebra 2 I teach it.
We'll get that this
Horizontal asymptotes. Horizontal, their y equals a number. If the biggest power is on top, there's no horizontal asymptote.
I remember that.
If the biggest power is on bottom, y equals 0 is the horizontal asymptote.
Yeah.
If the powers match on top and bottom, then you use the coefficients of the biggest power to make the asymptote there. Okay? So, biggest power on top, for instance, if this was x to the third over x to the second, that would be an example of no horizontal asymptotes. Biggest power on bottom, well, that would be if it's like x to the second over x to the third. Now it's y equals 0. If they match, then it's the coefficients. For example, y equals 3x cubed over 4x cubed plus 1. Okay, there's an example there where what's happening? The coefficient or the powers
The same.
match, and so then you're going to use the
numbers.
3/4, the numbers in front of those two pieces. So you would use the y equals 3/4.
I remember that.
Okay. Let's look at our example here. Determine any horizontal or vertical asymptotes of the graph. Okay, where do you want to start? Logan?
Well, I'm already just looking at her. I'm going to say that y equals 0, so then it's the horizontal.
Okay, are you with them for horizontal?
And my source is
Hold on.
the asymptotes. Notes that say the power's on the bottom.
Horizontal asymptotes say look at the powers. When we look at these powers, what's the biggest power on top?
1.
Well, the only power on top is x to the first, right? What's the biggest power on bottom?
2. X squared.
X to the second. The rest of that doesn't matter. I just care about my biggest powers. Where is the bigger power?
She's on bottom.
On bottom. So then that means my horizontal asymptote is
0.
y equals 0.
Boom.
Okay. Now, vertical asymptotes is set the, oh, yes? It was squared from right here. It was from this problem here. Okay. Vertical asymptotes. Denominator equal to 0. What's my denominator?
X squared minus x minus 2.
X squared minus x minus 2 equals 0. What do we have to do to solve that?
Factor.
Okay, if it's not already in factored form, you have to factor. So if we factor x squared minus x minus 2, x squared breaks into x and x. What multiplies to be negative 2 and adds to be negative 1.
2 negative 1. Or negative. Yeah.
2 and 1.
How about negative 2 and positive 1 though? What do we do from here?
do we set them equal to 0?
Yeah, we want to know what our asymptotes are. So the zero product property says you set them each equal to 0. When we solve these, what are we going to have?
2 and -1. What Logan said earlier.
X equals
That's
2,
what I was looking at when I said it. I have my answers.
X equals -1 when you solve those. Now, and that is, do be careful, right? Make sure you're thinking, okay, where am I at in this process? It is, I will say, a common mistake I see is that the students will look at this and be like, oh, okay, if -2 times 1 are the numbers I need, so those are my vertical asymptotes. Remember, you have to actually solve. Okay, with that in mind, if you haven't, don't graph it on the calc there yet, but I want to look at the graph.
So graph it on a calculator.
That's right.
What do we know about this graph right now?
Well, it can't equal 0.
Okay.
Up or down. So like,
There's a horizontal asymptote. Is that what you're talking about?
yeah.
There's a horizontal asymptote at y equals 0, which is the x-axis, right?
Yeah.
And then, what else do we know? There are vertical asymptotes at two and -1. Okay. Now, you guys don't know enough to graph this at this point, okay? But because of these asymptotes, I kind of know that my graph is going to be broken into 3 pieces. Okay? Something I think is more of a calculus conversation we talk about, though, is because this is positive, you begin graphing on the right, and it begins above the x-axis. Now, if I'm beginning above the x-axis, what's happening?
You're going up.
When I hit that vertical asymptote at 2, it's going to turn and go up. Because there's a horizontal asymptote, as my graph goes off to the right, it's going to be running along the x-axis. Okay? Another trick we talk about eventually is a vertical asymptote is going to cause you to change signs. So this piece of the graph was up and going positive. Now this piece of the graph is going to be coming from the negative. Another unique thing here is that with horizontal asymptotes, it's actually not a parabola in this case. Okay? You can cross through a horizontal asymptote in the center. Okay? You just can't cross through it in the end. And so this one actually does more of a cubic thing. It sometimes is a parabola if you have a squared function, but we didn't there. And then this, well, okay, a squared factor. Sorry, squared factor. And then this vertical asymptote causes me to change signs again. And so now this piece is coming from down below. And then as it approaches that horizontal asymptote, it runs out towards it. Okay? So, you graph this on the calculator. It's going to look similar. And as you guys are packing up, I'm going to show that real quick. So I want you to see the graph. Okay. We will finish notes tomorrow. Okay? And then you should have work time. I almost could have done this in one day, but we'll finish notes tomorrow. You should have some work time unless things go wonky, okay?